Hi, good afternoon, everybody. Looks like we have about 14 people here so far. That's pretty good, better than usual. Looks like the video's a little choppy. I don't know what's going on there. You guys, is the video stream okay for you guys? It looks like it's kind of choppy on my end. Make sure this is plugged in. Yeah, looks like it. Okay, so a couple things before we get going here. 2 weeks from today will be your guys' exam 3. So we have today's material, next week a couple days worth, then review, and then exam 3. So is the feed okay for everybody? Looks like it's stopping. I want to make sure that you guys are getting this okay before we get too far into this. It's good. Okay, hey Jenna. Okay, so what I will do, I have a practice final put together that I'm going to be sending out to all the instructors to give to all of their classes. I will post it on, it's a bit laggy. Okay, thank you guys. So I'll be posting that probably by this weekend. I want to just go through the problems again, double check the answers, and make sure that I have it right. Not that I send it out and the answers are not right. So even though it says final exam practice, I'm going to use it as your guys' exam 3 practice, and I'll probably more or less just change the numbers and the questions, and that will be your guys' exam 3. Again, for exam 3, you're only going to get one chance at it. You don't get 2 attempts this time. And so I want you guys to be real familiar with the questions and how you need to format your answers. So that's that. The second thing that I want to do for you guys is, so during spring break, I had gone in and changed the due dates for all the homework up to that point. So if you hadn't had any of the homework done, you could go back and do it. I know some people weren't around for spring break, and obviously with the whole pandemic thing going on, some people didn't get around to doing it. So I want to give you guys one more opportunity to bring your homework score up, which will of course bring your discussion grade up. And so to do that, if you want to go, I'm not going to change the homeworks for everybody because then it'll kind of affect what your guys' homework grade to date is. But if there are homework assignments that you didn't get to, or you want to go back and get a few more points, request an extension. It won't be automatic. It'll have to be manual from my end, but go into WebAssign, request an extension for those specific homeworks that you need. And then I will go in and grant you guys an extension. I'll probably do it probably up to exam 3. So after exam 3, doing homework at that point isn't, I mean, I guess it'll still help you for the final, but I want you focusing in on the final anyways by that point. So I'll grant you guys the extension up until April 29th. So 2 weeks from today. All right, so any questions on that? Any of the stuff with regards to the practice exam or homework extensions? All right, so today we are covering 4.1, 4.2, and 4.3. So chapter 4 has to do with the exponential function, the function e, and then logarithmic functions. And so 4.1 is on exponential functions, but the one that I really want you guys to know is the one that's in chapter or section 4.2. And here's where English and math don't get along real well. It's called the number e. So if you hit that on your calculator, it's like 2.718 something. But when you see this letter E in math, it's indicating this number. It's not a variable or something. It's actually the number E. And for you guys, the important thing here is graphing. What do these functions look like? So anybody going on to Math 181 calculus, you're going to use this function E just about every single day, or it's going to feel like that. So you need to get familiar with what does the graph look like, what are the domains, what are the ranges. So e to the x So it's never a negative number. You can't plug in any value for x, it'll give you a negative number. So technically, the x-axis is an asymptote. It's a horizontal asymptote. It'll never go below that value. So out at negative infinity, it's almost 0. And then when it crosses the y-axis, it's going to cross at 1 and then go up to positive infinity in a hurry. Because again, this number is almost 3. So when you start doing 3 exponentially, that number is going to grow very quickly. And the other function is e to the minus x. And if you remember from our transformations of graphs, when we have a negative inside the function, it does what? It flips the graph on the y-axis. So we still have this horizontal asymptote at the x-axis. But now when x is closer to negative infinity, the value is positive infinity. And once it crosses the y-axis at 0, it goes very quickly towards almost 0. It will never hit 0, but it gets very, very close. And then for 3, this is our introduction to logs. So this guy here, the basic log property. So this one, a good name for it, I suppose, is the Unstuck Log Property. So when you are working these log problems, be it in 4.3, 4.4, or 4.5, if you get to a point in the problem and you feel yourself saying, you know what, I don't know what to do anymore, I'm stuck, go back to this basic log property. Is there a way to manipulate the equation so that you can convert it into an equation that you can actually solve? So that's this basic log property. And then our properties of logs. So log base a of 1 is always going to be 0. Log base a of a is 1. Log base a of a to the x is x. And a to the log base a of x is also x. And then the other thing you need to know, and these are for your exams, is the graph of log. So e, we're in the top half here. So it never hits 0 and has this curve. With the log function, the basic log function, we basically have a vertical asymptote with the y-axis. So again, log will never take the value of 0, the basic log function. It's going to cross through 1, just like e to the x and e to the minus x did, and then it's going to flatten out as it goes towards infinity. So for your exam, you are going to need to know what's your graph of e to the x, e to the minus x. What's the graph of log x? You need to know these 3 graphs. So if you want to put those on your cheat sheet so you don't have to go back looking through your notes later, probably not a bad idea. And just the last couple things here, so we're kind of working our way back around the board. But when we have log base 10 of x, so we have all these invisible numbers in math. If I have x plus 3, that means 1x plus 3. We don't write the 1. If I have the square root, I don't write the 2 for the root. And now with logs, if I have log base 10 of x, I just write log of x. It's implied that this is base 10 if there's no number written. So it's that invisible 10. And then we have what's called the natural log. So when we have log base e of x, this is called the natural log, and we can rewrite this as just natural log of x, ln of x. And the properties of natural log is natural log of 1 is 0, natural log of e is 1, natural log of e to the x is x, and e to the natural log of x is x. And again, for Math 181, if you're going on to calculus, you are going to want to be very familiar with those properties. Because again, you're going to use them not every day, but probably half of the semester's worth. You're going to use these relationships between e and natural log. So let me get out of your guys' way there and get out of the light. So All right. So any questions on any of that? Again, this is all stuff from the videos, but just want to make sure you guys know that this should be the important things, especially these graphs and this basic log property. That's probably the most important thing there. All right, so let's get into some of the homework. So one thing about, so I have you guys post the problems that you guys want to see, but a lot of problems now are getting posted where it looks like you guys haven't even tried them. It's just like, oh, I want this problem worked. So maybe it's that you don't know how to start the problem. So about all I'll do for those is tell you how to start it. Again, the purpose of this whole process we're doing is not, for me to do your guys' homework. It's to help you when you get to a point in the homework where it's like, okay, I've tried a bunch of different ways. I can't figure it out. Now I need some help. But if it's just a case of, well, this problem looks horrible, let me have them do this one, I'm not going to do that. So if it looks like you guys are just posting problems without even trying them, I'm not going to work those. So let me go to Canvas here and see which ones you guys needed. I didn't write them down. There was quite a few of them, so I figured I'll just check back to this and use this as reference. All right. So looks like 4-3, number 12. So we'll kind of jump around here. So 4-3, number 12. F of x is log base 3 of x. And you have to fill in this table. And it's, what was it, I think 3 squared it started at. Yeah. So you have 3 squared, 3, what was it? 1, is it 1 or 1/3? Maybe I should have written these down. Yeah, 1/1/3, and 1/3 squared. So this is essentially getting you to use those properties of logs. So if I start at the bottom of this table instead, if these are my values for x and I want to know the value of the function, well, this would be what? Log base 3 of 3 squared. And so by our log property, when we have log base a of a to the x, it's just equal to x. So these 3's more or less, if you want to think about it, kind of cancel each other out. So the answer would just be 2. And this guy, 3 is what? 3 to the first power. So this is log base 3 of 3 to the first power. So using our properties again, log base a of a to the x is just x. So this is 1. And this will just continue through the way for this whole table. So that's how you would want to work this problem. Number, can't tell what problem number that is, but another problem similar to it, same idea. Let's wait on the domain ones here. Let me see if I can find some stuff from 4-1 or 2. Okay, so here's one several people had a question on. So in section 4-1, number 3, so your function is 4 to the x plus 1. F of x equals, yeah. And it gives you a table, and I can't really tell the numbers there. But the one that seems was giving everybody trouble was this guy here. And so the other ones are just going to be the same idea. So remember this function notation. What does this mean? It means we take what's inside the parenthesis, plug it into the function. So this is 4 to the e plus 1. So now you're going to have to use your calculator. On your calculator, you hit the E button. Add 1. That's going to give you some number. And then whatever number, so it's going to be roughly, well, this will be about, what, 2.713. Because E is 2.718. Add 1 to it, 3.718. So this guy is basically 4 to the 3.718 power. And again, you'll have to use your calculator for that. Just plug that into your calculator. That should give you the number that you need. And let me check the other part of that problem. So the other part was the fourth one, which is f of -6/5. So same idea. We're plugging this in for x. So you have 4 to the -6/5 plus 1. So simplify this fraction. That'll give you 4 to some power. And then again, you're going to need your calculator. 4 to that power gives you what number? So these are calculator ones. These are just basically calculator problems. There's no way you can do these without a calculator. So that's how you would work those. You're just taking the number inside the parenthesis, add 1 to it, and then take 4 to that power. Let's see. All right, 4-2. Looks like 4-2 and 4-3. So the same idea. It's just you have your e to the x. So 4.2, number 2. You have, what is that? Yeah, e to the x. So h of x is e to the x. And you're given a bunch of numbers. So h of 2, h of 0.51. Yeah, 0.51. H of 1. And h of -2. So again, it's a calculator problem. It's your functions. So h of 2 is what? Well, you just plug into for x. So use your calculator. That'll give you some number. Same for this one. Now x is 0.51. So e to the 0.51. Use your calculator. That gives you some number, etc., etc., etc. So any questions on that? These are the same as what we were doing in chapter 2 with the functions. It's just now you're plugging in to the function e instead of like squaring the number or something like that, whatever the other function was. All right, let's see what else we got. And 3 is similar. Okay, so Taylor's asking how we entered into a calculator. Okay, so that's a valid issue then too. So unfortunately, with me being here and you being in your house, it's extremely difficult for me to tell you how you would enter in your calculator. Some of it, like you guys can just enter the equation in and you hit enter and it gives you the answer. Some, if it's like mine's a more basic calculator, so I have to kind of do it in a few steps. But is that h of x? Is that -2x maybe? So can you guys confirm, is that number 3? Is it h of x is e to the -2x? Kind of hard to see for me on the screen prints there. When you guys post these screen prints, if you can kind of get it as large as possible, that way when it's posted to Canvas, I can see what the numbers are, because sometimes on the posts, they get real small. You guys can see once you post it. So yes, that's it. Okay, thanks, Taylor. So the first part here was the h of 1. So the first question wanted h of 1. So first we have to plug this in. So this becomes -2 times 1, so just -2. Now again, depending on your calculator, so like the calculator I have to hit the E button, and then I have to hit the Y to the X button, and then I enter in whatever, -2, and then that just kicks out the answer. So E, Y to the X, -2, or I think I have to equals. So then that gives me the answer. Now again, depending on your guys' calculator, it might be, so maybe the way to do this, I don't know if you guys have heard of Wolfram Alpha. So you can use that, and maybe Mathway as well. I know some of you guys use Mathway, but Wolfram Alpha. So Wolfram Alpha, when you first open the page, there's like a line at the top where you can enter in things, and then you hit the equal symbol, and it gives you the answer. So if you go to this site, if you wanted to calculate these there, if you're having trouble with your calculator, you would just type in E and then the little caret, the symbol above the number 6 key on your keyboard. And then I would do parentheses -2. And then over at the end of the bar, there's a little equal symbol. So once you have this entered, hit that, it'll process and it'll tell you what the answer is. So maybe that's the way to go with these if you're having trouble with your calculator. Again, if we were in class, it would be a lot easier. I could come around and try to help you. But these are probably the two main ways. Either E, Y to the X, -2 equals, or if you're entering in on Wolfram Alpha, E to the what power, -2 equals. Now, I will tell you, on the final exam, and so I guess probably on exam 3, you will have some problems that you need to calculate something like this with a calculator. And so before the exam, whether it is Wolfram Alpha or if it is your own calculator or Mathway or whatever you use to calculate numbers, make sure that you know how to do these types of problems because you will be expected to do them on the exams. It'll say, calculate this, round your answer to 2 decimal places or something. So you need to be able to do that. So any other questions on that one as far as, again, trying, so not just the methodology behind it, like that, but as far as a calculator, it's just finding a resource that is going to work for you guys. All right, so then next thing that I want to talk about. 16. Yes, it's the domain problems. So okay. All right, so up until this point, yeah, you're welcome. Hopefully you can figure it out, or hopefully you can use one of the resources. All right, so up until this point, when we've been talking about domain, we've had 2 issues. And they are what? Is there an even root? And is there a denominator? Those were our only 2 concerns. Anything else didn't bother us. It would just be the real numbers. It would be the domain. Today, we add a 3rd concern to this situation, and that is the log function. So again, let's look at the graph for log. So log base A of x It essentially has the asymptote at the y-axis. Goes through the point 1, 0, but it's never 0 and it's never negative. So if I want to find the domain for a log function, so all right, let's do this like we were doing the concept questions before. If I had an even root, how did I find the domain? I set the radicand greater than or equal to 0. If I had a denominator, what did I do? Well, I had to find out what values would make the denominator equal to 0. And the third situation now is that log base a of x, this x is related to these guys here. So it's never going to be 0 and it's never going to be negative. So to find the domain for a log function, what I do is I take this piece here and I set it strictly greater than 0. And then I solve it from there. So goodbye to that guy. All right. So does that make sense to everybody? When we're dealing with domain, log function is now a big issue for us. It's based off of this graph, and it can never be 0. It can never be a negative number. So let's look at an example before we do the ones, something a little maybe more straightforward. Well, no, let me look at the homework problems you guys had, because maybe we can just do those. What is that? So number 14, I guess. And again, if you guys can make these pictures bigger, but looks like log base something. And honestly, the base doesn't even matter. I don't care. Is that x plus 8? I can't see what it is on there, so I'm just going to call it log base a. So if I wanted to know this, so was it f of x? If my function is log base whatever of x plus 8, then my concern is what? This piece, x plus 8, has to be strictly greater than 0, not greater than or equal to. Greater than or equal to is for our roots. For logs, it's strictly greater. So now we just move the 8. So x has to be greater than negative 8. And how do they want the answer? Interval notation or, yeah. So they want the answer in interval notation. So that would be what? Parentheses negative 8 up to infinity. Does that make sense to everybody? Any questions on that? Yep, it seems to be that way. So apparently they're done trolling everything else, so now they've moved to the educational videos apparently. So anyways, I tried to block them all there. Hopefully I did. All right, let's move on to the next problem. And hopefully this type of question on the board, a value isn't including. No, so it literally does not matter what the base is. Yeah, so and that's why I said that even though I couldn't see it in the problem, it wasn't really that big of a deal because the base has nothing to do with the domain. All I'm really concerned about is this piece here, and that has to be greater than or equal to 0. All right, so let's move on to the next question. Any other questions on this before we move on here? Okay. So let's see. So number 15, I'll have you guys try that. Aha, yes, okay. So again, I can't see what the base is. Well, so we have log, so this is 15. Log of some base is x squared minus 9. So go ahead and try that one. So see if you can figure out this domain in interval notation. Base is 4. Okay. Thanks, Wilson. Again, so yeah, I appreciate it. So we have it, but the base doesn't really come into play when we're figuring domain. Our bigger concern is what's in the parenthesis. So when you guys finish this, just tell me done. If you want to if you want to post your answers, that's fine too. Meanwhile, I'll put all these jackasses on timeout and hide their stuff. So, okay, Alejandro, my guess is that's not correct. Let me see here, but I don't believe that's going to be it. Okay, thanks, Cassidy. What'd you get for an answer, Cassidy? Yep, I think that's right, Jenna. So what do you guys have here? When you set this up, you're going to have what? X squared minus 9 is greater than 0. And so that is a what? That is a nonlinear inequality. So remember, we've encountered a few of these. Yep, I think you guys now with the union there, I think you have the right answer. This is a nonlinear inequality. So you need to set that up with your table and your breakpoints, et cetera, et cetera. So we've had a few of these. They kind of sneak in on us every now and again, especially with these domain situations. So yeah, so try this one as a nonlinear inequality. So x squared minus 9 is greater than 0. And then solve it from there. And you guys should get the answers like Wilson, Billie Jean, Jenna. Yeah, like you guys are posting, Cassidy. Yeah. So I think that's the answer. And once you get that, or if you don't get it, then just tell me done again so I know you guys aren't waiting on me. What do you mean? How do you post answers, Marco? So I don't know why today these guys are all in here. Maybe tax day. They're all working off tax frustration or something. But I'll look into this maybe next week. Starting next week, I'll put like a password one. Is it just so on this one, like you just type it in the answers like they did above. So parentheses, negative infinity, comma, -3, etc. Just type that in, type your answer. All right, so let's go ahead and look at this one. So you guys were on the right path. I think it was just kind of threw you off because of the nonlinear. We have x squared minus 9 is going to be greater than 0. So factoring, this is x plus 3, x minus 3 is greater than 0. Again, this is a nonlinear inequality. So I use these two values. X plus 3 is 0, so x is -3. And x minus 3 is 0, so x equals 3. So those are my breakpoints. So -3, +3. So if I pick test points there, say -5, 0, and +5. So plug those into here. So -5 minus 3 is a negative number. -5 minus 3 is a negative number. Negative times negative means in that interval from negative infinity to -3, that value is positive. So that's for that one. If we plug in 0, then we get what? 0 plus 3, that's a positive number. 0 minus 3, that's a negative number. Positive times negative is negative. And plug in 5, we get positive times positive, which is positive. And I want what? I want when this product is greater than 0, that means I'm using the positive numbers. So it's what? Negative infinity up to -3, union 3 to infinity. And I cannot use these endpoints because if I plug in -3, this thing is 0. 0 is not greater than 0, so the endpoints are not included. So it gets only a parenthesis at this point. So does that guy make sense? Any questions on that before we do 16? All right, so number 16. All right, good. So 16, we have natural log of x. I can't see, is that plus natural log of 8 minus x? Yeah, it looks like it. Plus natural log of 8 minus x. So this one, okay, thanks. This one is similar to the domain problem we had before with the numerator and denominator. We had to figure out the numerator, figure out the denominator, where's the overlap. So same thing here. Figure out the domain of this piece, figure out the domain of this one, and then what's the intersection? So figure these both out separately, draw them on your number line, and where's the overlap? that's going to be, and let's make this one the attendance problem. So go ahead and try this one. Again, you're going to figure out both pieces separately, and then what's the overlap. All right, Billie Jean. Well, I'll tell you what. So I will post, since it's normally only like the usual suspects here, the handful of people. Okay, guys. Maybe we'll do Zoom, and that way I can kind of see you guys face to face. You can ask questions if you have questions. Then it's password protected. I think I can still record those. I'd have to double check. But with all these jackasses here, I'll see if I can do password for these videos, make them private, and then give out a password or something maybe. And then I'll just email you guys the password. Then it eliminates all these guys screwing around. So. Okay, okay, perfect. Yeah, so that will maybe be the other option. And I have to check too. I know there's a 40-minute limit, but I think with this online class stuff, they've granted extended time. So I'll figure that out too. Maybe we'll do that for the last few classes, just that way we don't have all the interruptions of these a-holes, for lack of a better word. Excuse my French, but that's how I'm feeling at this point. So, all right. So let's do both of these. For this one, it's pretty straightforward. It's just what? X has to be greater than 0. For this one, 8 minus x has to be greater than 0. So if I move the 8, I get -8. So negative x is greater than -8. To make x positive, I divide by -1. But when I do that, don't forget, with inequalities, when we divide by a negative, we have to switch the inequality symbol. So this means x is less than 8. So if I draw these on my number line, I have 0 with an open circle going to the right. And for this one, I have 8 with an open circle going to the left. So then my overlap is where? It's everything from 0 to 8, but the endpoints are not included. Remember from before, an open circle wrecks everything. So these are going to be parentheses on both of these. And if this is on a test and you want to check your answer, just pick a number that's not here. So let's say -5. Well, if I plug in -5, what happens? I get natural log of -5. That doesn't work. I can't have that. So I know that nothing down here is fine. How about something outside of 8, say 10? Natural log of 10, that's fine. 8 minus 10, well, that's a -2. So that one's not going to work. So I can feel pretty confident that my interval 0 to 8 might be right. So that's one way you can sort of test it. Does it make sense? is it possible that that would be the answer? Oh, yeah, okay, 145. So any questions on this? Anything else? So again, those first few questions, I guess maybe it's just like a methodology. What did you have to do? The important things from this are the graphs, like I told you, the basic log property. You're going to use those a lot on 4.4 and 4.5 when you're solving log equations. And then the last thing is the domains of logs. So I can tell you that on your exam, at least the final exam for sure, you're going to have two like we had before, radical, denominator, and now you're also going to have a third domain question, which is the log function. So any questions on anything we went over today? If not, I'll give you guys the ticket out the door before we get too many other knuckleheads in here. So. Speaking of knucklehead, there you go. So, all right, no other questions from you guys? All right, so your ticket out the door for today then. So you have 4 questions today. Number 1, sketch f of x is equal to e to the x. Number 2, sketch f of x is e to the minus x. 3, use a calculator. And if f of x is equal to e of x, calculate to 3 decimal places. So the first one is f of minus 3. The second one is f of 0. And the third one is f of 2. And last but not least, right. Number 4, state the domain. An interval notation of f of x is equal to log of 3x plus 1. Yeah, I know. It's getting ridiculous. So I will. Exactly, Wilson. Yeah, I know. I guess they're going stir crazy sitting at home. So they figure let's screw around with people that are actually being productive. So bye, Jack. Have a good life now that you're banned from this one. Bye, Ian. Have a good life. Anyways, you guys, yeah, so I think we'll do that. So let me give you the answers to these. And if you guys want, I can do a Zoom at like 4 o'clock or something if you have an issue. Otherwise I can do these like Monday or something. So we'll just do that. I'll let me give you guys the answers to these so that these guys don't have any more anything else. Nah, it is what it is. So I guess we're lucky we made it this far into the semester with these chapters. So number 2, you get that for the sketch. So this one you should have 0.050, 1, 7.389. Yeah, I will. I'll definitely try to record it, because what I may do for my 2:30 class is set a Zoom up for that as well. So I don't have to deal with this again later. But anyways, and then this one, the last one, you have -1/3 up to infinity. So those are the ones there. So those are the answers. So I'm going to go ahead and shut down the cast here. These guys will have to go find something else to do. Obviously, if you need to, you can always pull the video back up to get the answers. And then on Monday and the semester, we'll just plan on Zoom. I'll figure out how to record it, and then I'll get it posted somewhere for you guys, hopefully. But then you guys don't have to deal with things. I'm more concerned about you guys. I don't care. They can say what they want, but I don't want them to be such a distraction that you guys aren't figuring this stuff out. So there's your answers. You guys have a good weekend. Sorry for the nonsense here today, but be safe. Weather's supposed to start getting nice. Try to get out, get some vitamin D, get some fresh air, and we will see you guys probably in person on Zoom on Monday. So have a good night. We'll see you later.